Okay. So this is an overview of what we have done so far. I told you when you're about to start your meta-analysis, you can install two packages. So majorly, the two packages you can use on R is Meta4 and Meta. But so far we have been using Meta. So what you just need to do is to install both Meta4 and Meta. So in the last class, I think I showed you just what you just need to do is type install.packages Meta4 and install.packages Meta. Then you can call on the two of them, library Meta, then library Meta4. Then if you are using a CSV file, in which I advise that if I'm collecting my data now, let me show you this. You already know that you are collecting a continuous data. So this is what I have here. So all I need to do is like in those papers, we are going to like try something, a sample like this. So I will have this column written this way: study, the sample size, the mean, the standard deviation, the sample size of the control or the comparison. Then this was the one I was just trying to. Then I told you about the moderators. Last time I didn't talk about moderator. So the moderator could be anything that you are looking out for that you feel could affect the results of your experiments that you want to like probably consider. Now, I think, okay, let me give you an idea here. This particular one I was working with is, I have different kind of studies, study 1 to study 8, and I try to see the effect of fertilizers on maize yield. Now, this were this for the study 1. When I look at the sample size, the researcher used 30, then the mean was 15.2, then the standard deviation was 2.5 that was recorded. Then I also checked the control and I have this. Then these experiments, I want to see, because we know that the time at which the fertilizer is applied could also affect the kind of results that we have. So I noticed the duration there is 4 years. Like after 4 years, what was happening? Then for study 2, it was done for 6 years, up on to like study 8. Then you as well record the year at which this thing happened. Now the reason behind this is these are the moderators. Now let me just give you an can someone just give me what they are currently working on? Then we'll try to get the moderators. I think I've explained moderators before. So you can give me a research question and let's try to look for a moderator that you can as well just look out for.
Okay, hello.
Yeah, I'm with you, Abdullah.
Okay, the topic is the effect of stress on the egg production of 16 weeks layers.
Okay, the effect of stress
Mm.
of the effect of
To be
stress
precise, heat stress,
the
please.
effect of heat
Pardon me.
stress.
Yes,
Okay, go ahead.
on the egg production
On the egg production
of
of what?
20 weeks layers. 20 weeks.
20 weeks
20.
layers. Okay,
Yes.
now that's your research question, the
Mm.
effect of heat stress on the egg production of 20 weeks layer.
Mm.
So what do you think could result in heat stress? Now, can affect this the egg production of this 20 weeks layer? What do you think? What are the moderators for heat stress?
Okay, firstly, we can have maybe overfeeding. Overfeeding can be a moderator there.
Can
That's
result
one.
to heat stress?
Yes, yes, when you overfeed them.
All right, all right. So now the thing is, something that you have to note is, now if you are looking out for papers in this kind of thing now, like you are looking out for paper that report on heat stress, right? On egg production. Now for 20 weeks layers. Now your question is, what did you want to look out for? Let's be practical now. Like What do you want to look out for?
Hello, please, what did you say? Please, I didn't hear you for like 5 seconds or six.
Okay. So I said let's be practical now. Let's say we are trying to like start your systematic review. Now,
Okay.
you will have a question that says the effect of heat stress on egg production of
Mm,
20 weeks layers. Now, what's
mm.
your comparison? Who are you comparing it to if you are using a Pico framework? So what would be your
I'm
comparator?
comparing. I am comparing it with their because this one's their indigenous ones. So I'm comparing it with their foreign counterparts.
Okay, that means your question is not clear yet, like your topic.
Yes,
So
yes, 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 yes,
okay, so if you are
yes.
saying which kind of, you should have a breed of probably
Yes,
layers that
yeah.
you're looking out for. So
So
in the
let's
local
just call
breed,
them breed A. Let's just call them breed A. Yeah, let's call it the local breed, then the
okay,
exotic breed.
the
Yeah,
exotic breed. So now
yeah.
you should now from that alone, you already know that you're trying to see how if each stress affects egg production of 20 weeks let's call it local breed. Now your
Yeah.
comparators should be those exotic breed. Now
Mm-hmm.
the question you are trying to, you already know, you want to know how each stress affect their egg production. Now you need to get the next thing you need to do for your meta-analysis, you'll be looking out for papers that report the sample size, the number of sample that they use to study this thing, then the standard deviation when they measure the change, then also they should be able to tell you about the mean. Are you getting it?
Yes, yes.
All right. So you need those papers that report these things and the controls. What were the control? What are the main of the control that they use? The
Excuse me. It looks like you are not. Are you presenting your screen, your Excel screen?
no, not right now. Like I'm just trying to
Okay.
explain. All right. So I'm just trying to be practical a little bit. So you need to get these data from them and the control. That means in those papers that we are looking at, I think we'll try that right now. So in those papers that you are looking out for, you look out for the control there too, and you report those mean size. Then the next thing you put there is, okay, I want to know this information now. Okay, the control, these are the information I know. Is heat stress truly affecting the egg production of 20 weeks layers? What could moderate it? Temperature difference, location. I hope you know that since you are trying to compare local breed with
Yes.
so you should know that location will definitely affect them. So I can just put location there. I might decide to use it by continent. Oh, Africa, Asia, this, my paper will be like that. So when I'm doing my sub analysis, it makes it more very easier, subgroup analysis, to see if actually, you know, all the papers you had now, they are of different continents. Let's say I have about 30 papers when I got those papers and I report them. Let me show you this. Make it more easier. Now I have something like this. Study, then let's call it NE for your experiment. Then we have ME, then SDE, then we can have NC, NC, SDC. Then what will be your moderation? Your moderator could be location. Now you want to see truly if location could as well affect or influence heat stress on egg production. So you can also think about some other things like, okay, that you feel you would want to look out for. What are the other questions that you want to look out for in the work or in the papers? So all I need to do is report this paper. Okay, study one, the name of the study, what were the sample size that were reported. Then for a, what did you call it though? I think a local breed. Yeah. So you have to like record that here. Then same thing, who is your comparison? What did they compare it to? So it simply means that your topic should be those that use their control as either exotic or the local breed. So you record what they also, the main differences here. Okay, where is the place? Is it Africa, continent Africa? Then same thing, probably I have Asia here, then I have Antarctica here, papers like that. Then this thing that I have here, after recording everything, then what I just need to do is save it as a CSV file. So anywhere you put it, so, and okay, this is already saved here. So but what you need is like you have to save as CSV comma delimited. If you save this one is already saved, so then that's when you can come straight up to your R. Now it depends on a lot of questions that you want to answer. So at the beginning of this class, I think I was telling you that you're supposed to have written those questions that you wanted to answer. I want to answer this question. I want to see how this impacted this, how this impacted this. That will tell you the kind of data that you want to collect. Then from there, what you just need to do is you call on your CSV file. Please ensure that the CSV file that you are calling is in the same file location working directory with your R. So if you notice here, this is how to use the working directory. That's an overview of this class. So all you just need to do is type get wd working directory and you run it. When you run it, it's going to tell you the working directory where you have this particular alpha is operating. If you look at mine, it's under the document. So if I save any file under that document, like the Excel, the CSV file I want to make use of now, I have to put it on in that document. So my R can easily go there and pick it up. So now then I can run these arguments or this method r.csv on the name of this CSV file, then save it in a variable called data. Then when I save it in a variable called data, I run. So you can see what it's showing me here. That means it could locate where this file is, and now currently the file is on this variable called data. If you go to your global environment here, you are going to see the same thing. Can we see that? Are we together?
Yes.
All right. So if you look at the global, I just took this from the global environment because you have you already called that into data now, so it's available in your global environment, so it's not difficult now. So even though when you call data, it shows here on your console, so it's good that you check it after like calling or saving it on a variable, so you can check if there's probably a mistake somewhere or a mistake had been done, so you can correct it. Then the next thing you need to do is same way for you to run the analysis. Just as I said the last time, you need to call on this function called meta continuous. So if you use another name to represent, then you save it rather on another variable called meta1. You can call it any name. So but if you name this NE, because NE is like the inbuilt function or the inbuilt name rather for sample size of your intervention on this method or this function. So if you use any other name, that's when from the last two videos or the last two class, you see me use equals to, then I like just put like I'm telling this particular thing that okay this is what I used to name it on this file. I did not use NE, but if I maintain NE like what I did here, I maintain NE, so I don't need to like use the assigning thing again. So all I just need is to call on those variables down to this place. I believe we also know what study lab just help us tell us when you do the forest plot, what would be the name of the x-axis there. So what do you want them to call that studies, all the whole studies there. So I decided to call it study. Then data, where is the data from? So you already saved the data on this called data. So if you call it another name here, you have to like tell us okay, it's saved on this particular thing here, this name that you gave it, and I maintain data because don't stress my head. So What kind of um, effect size did you want to measure? Like, okay, I might decide to use standard mean, SMD is standard mean difference. You might decide to use mean difference. You can read up why people like to like utilize standard mean difference, but most times people want to use mean difference, like standard mean difference. And there are different methods. If you remember the method of the we used this in the last class, method of SMD. There are different methods you could use. You can use edges, you can use Cohen D or Cohen Q. So just check them out. It's still acceptable. They are all doing the same thing. It's just like different formula of calculating the effect size. Then from the last class, I also talked about you using fixed and random. You can check the last video. So most times we use random because we believe that most of the studies are not from the same place. So then when you are done putting in these values, so all you just need to do is to run it. Okay, I think there's an error. Could not find function meta count. Meta counts. They are under the meta and meta for. So if you don't run it, it won't work. I believe it should work now. Yeah, so it's working now. It's working now. So after that, all you need to do is your summary. You call on the summary what's named. So you can see the summary. I don't need to explain this all over again. I explained that in last video, last class rather, on how you could understand what this thing simply means. So then we have our forest plots here. You can run your forest plots. So then you zoom into it. I believe by now we all know what this means. So it totals it and it tells you the pooled effect. The diamond here is a pooled effect. I also showed us the ways we could like add beauty to these things. There are functions that things we can add: column color, row color, diamond dot color, those things that we did last time. So just to probably you want to make it red, you want to make it blue, just add your own touch to it. But if you want to maintain it this way, it's quite fine. As well, just to remind you that this is the pooled estimate here. And if you look at the pool estimate here, it's 95% confidence interval. It's beyond zero, which simply means that it's very, very significant. Then if you go to this heterogeneity, it's telling us that there is no variance. You know, I said when it's above 50 or 70, from 70, it's already becoming very high. So it's telling us, oh, there is no variance here. But if there is variance, what you just need to do is the next thing you just need to do after this is to run the forest plots, the funnel plots. But most times, as I said, you might as well decide to just edit it like the way it is showing right now, add color to it, give it, and that's where this function comes into place. XLab here is to tell you, okay, the x-axis, I want to name it standard mean differences. Now, if you look at what we have currently, this is the x-axis here. There is no name here, so I might decide to name it and just put standard mean difference under here, so it makes it more easier for understanding. Then I might also say, okay, I don't want to report like the mean difference, the standard mean difference, everything all around, like the way it is here: total, mean, standard deviation, total. So I might just say, okay, I just need the mean alone on my table. Let's go back to the arrow. So I'll just say the left column. Okay, what I want in my left column, I use C to like put those things, the names. So study lab, I want my study lab to remain. I need NE, that is the sample size of the experiment and the sample size of the columns. So what I'm saying that I don't need mean, I don't need standard deviations for all these things. They should just go away. So then the right column, I only need the effect size and the CI. So when I run this, you see the difference between it and the previous one now. So it's going to change. Some things will leave now. Now, do we see it? It's just giving me the sample size of the the intervention and the sample size of the control, and I have my mean difference just to reduce what I have here. But depending on the journal you are submitting it to, some might require you to leave it the same way, so you can just make changes the way you want it. Then finally you go to your funnel plots. The funnel plot, we all remember what the funnel plot is. So the funnel plot is just to visualize that you want to visualize whether there is the table, rather the papers that are used in the meta-analysis, was there public, were they symmetrical or they are asymmetrical. So though it's not a true, some people usually end here, so let me just run it. All right. All right. So this, when you just do the funnel plot, this is what you're supposed to have. So if you look at this visually, we could say, oh, this, most of the papers were within the triangles. They might not even be within the triangle. You can just tell that, okay, these things are symmetrical, but it is not. You cannot just give an assumption because it's very, like, you are just looking at it virtually and you are concluding. So another method was brought up to do this, and that method is called Eagers regression. We'll call it Eagers. This was where we stopped the last time. Eagers regression analysis. Now, Eagers regression analysis would now check if truly what you claim here is symmetrical. Now, is backed by statistics. So if the p-value is less than, if p-value is less than 0.05, so you are saying that it's statistically significant, meaning that this thing, are you with me, guys? Can you guys hear me?
Yes, sir.
Yes.
Can hear you, sir.
All right. So if it is statistically significant, meaning that it's actually symmetrical. Now let's do this. Now, if you want to do the Eagers regression, what you just need to do, the function you need to call is meta bias. So we use meta bias as the function we need to call on. Just type meta bias. Then what is the name of the data that you want to run this publication bias test on? So we call it meta 1 when we were working earlier. We saved it under meta 1. So all you just need to do here is call meta 1. Then what is the method of bias that you want to utilize? There are different methods of bias, so I'll just tell you to stick with one. Master, understand how it works. So the first method is link reg. So you can check more, but just maintain one. For now, just maintain one. Then just try to learn more about how does link reg work, what does it calculate for, something like that. Then you can just call on this. What's happening? All right. Now, if you want to do Eagers regression, if you see the warning message it gives me here, number of studies k equals to 8, too small to test for small bias, more study effects. So the minimum is 10, meaning that the number of study I can use to check publication bias, the minimum is 10. But if you want to do this, just ensure that you have up to 10 study. But if you don't have up to 10 study, you can as well do the same thing. What I just need to do is I'll come into the function and I'll change my k minimum, the number of study. K is just the minimum, the number of study, and I'll change it to 8. I think it should work. Okay, I'm supposed to put it in a colon. A quote. Okay, let's run it again. Came in. All right, I think there's a bug.
I think it's the spacing.
Yeah, that's one. So let's try this. Oh, it is working now, I think. What's happening? Object metadata. Is it working here? Unexpected symbol in the meta bias. Can you guys still hear me? Hello, are we together?
Sir,
Can you guys still hear me?
sir, sorry, sir. You said the minimum is 10. I don't know. You put it
Yes,
there.
yes, the minimum is 10. But all I just wanted to like practice, like I just want us to like practice how to use EGAS regression. So then I decided to like the default here is 10, but I decided to change it to 8 because I have just 8 studies and I still wanted to do that. Do we understand it?
Yes, sir.
All right. So when you are working, please don't add K minimum. Just ensure that your studies are up to like 10. It makes more sense. It makes more sense. But just because I will just want us to learn, but I just make use of just 8 studies. So I had to change the minimum number of studies to 8. Then we can go ahead that way. Then now you come down here to see. Now this is the report from the linear regression. It says linear regression test of funnel plot asymmetry. Test results, degree of freedom, p-value is 0.1850. Now look at the p-value that we need here. Now since the p-value is greater, if the p-value is less than 0.05, that means that this thing is significant. Like, can you still hear me, guys? Said that if the p-value is less than 0.05, you are trying to say that there is publication bias. That means that the thing is asymmetrical. It's asymmetrical. So I can just write asymmetrical, meaning that that thing is not symmetrical. But if it is greater than 0.05, it means that the study is actually symmetrical. The study is actually symmetrical. If you look at this, it's greater
I
than
want
0.
to ask you something, please.
Yeah.
I think the significance or non-significance, I think we can also observe it from the funnel plots also.
The funnel plot is not a true identification whether something is significant. It's just like you are looking at it virtually. There are some that can enter directly into it, but at the same time they are not significant. They are not symmetrical. A
Okay.
virtual representation, that's why we said scientists actually come up with this. They notice that this thing is not truly true, so they decide, okay, let's have a stats behind it. So from this stats behind it, when you do this, when you run this and it is less than 0.05, you can say that this thing is asymmetrical. But if it is greater than 0.05, it is symmetrical.
Okay, but the this p-value is giving us is we are talking about all the studies included.
Yes,
Like,
yes, all the studies put together.
okay,
It is those studies you want to see when the studies when they are put together, like, are they actually symmetrical on the funnel plots? Like, are they symmetrical or they are
okay,
symmetrical? If they are symmetrical, you are tending to, are there funnel plots try to check if there are publication bias. But with the funnel plots, you cannot, it's not like a 99 or 90% confidence that, okay, what you said from what you visualize is truly what it simply means.
I understand. I
Yeah,
understand.
so you now use data to back it up. Imagine just saying, after running funnel plots, we identify that most of the like, it is symmetrical because most of the data fall into the funnel or stuff like that when you are reporting. But just imagine somebody else back it. Well, okay, after running the funnel plots, we decided to like check EGAS regression to identify if it is significant at 0.005. Then we found out that it gave us a test result of this, copy this thing like this and put it there. And with a p-value of 0.1850 greater than 0.05, which makes it symmetrical and shows there is no publication bias. That's like a confirmation study starts
Yes.
to what you are saying. I don't know if we got that.
Yes, yes, I got it
Oh,
now.
all right. So that's what we called like we used to check publication bias. So use the gas regression to check publication bias. So if this thing is less than, you can now say, this thing is actually very, very less. So yeah, then we can now move forward. Another thing that I want us to know is subgroup analysis. Now, subgroup analysis is also known as the moderator analysis. You see, all these things are simple. So they are the moderator's analysis, meaning that you want to see how those factors that you are looking out for, do they truly influence the result that you had? Now, let me show you this. From what we have here, looking at almost all of this, they did not cross the standardized mean difference, meaning that all these studies here are very significant. Do we get that? If you remember the interpretation here, and if you are
Yes.
using the confidence interval, you see they do not cross zero. All of them do not cross zero. They do not cross zero. So they are all these studies are very significant. And the effect size, if you watch the box, that means the sample size are not far different from each other, which makes this study very, very nice. And that's why when you run the heterogeneity, it's telling us that it is zero. There is no heterogeneity. That means there is no variation between the studies, because the sample size are very, very close, which is very, very good. It's a very, very good study. But if the heterogeneity is high, close to about 50 plus, I might decide to want to know. The reason why I go for further analysis is for me to know, okay, what could have been causing the variation? That's where from your moderators, could it be because they were done, like the study were done for the duration of 2 months, 4 months, 6 months? That tells you more. Now, if I have this, and with this one, I would decide not to go further to check probably EGAS regression. But if I just want to like back it up, I might do EGAS regression. But if I'm having close to about 50% heterogeneity, I want to know what could be the factor, what is causing that variance. So some people will now do what we know as the subgroup analysis. Now, how do you run the subgroup analysis? I can run my subgroup analysis in this method, but I just don't want to use this method. I just say it might be so stressful for us, but it's still the same thing. So I decided to use this. Let's use, okay, yeah. So we'll be using this. We'll be using this. So still same method. All you just need to do is same meta count, call on your data, put in all the same thing you had, but now you are saving it into another variable. Instead of calling it meta, we want to do funnel. We want to run a funnel analysis, like a funnel. Sorry, is it funnel? No, we want to do a forest plot for this. So we want to see if the subgroup were like the pool estimate of each of these subgroup, and what are our subgroup, our moderators here. If you go back to the data here, you will notice that, okay, let me use the data here. I said the moderators could be, okay, the study was done in 4 years, 6 years. So I want to know whether, then I decide to group them. So I can identify if each studies that were probably done in a shorter time were the one that were influencing the results for this thing to be very statistically significant, meaning that the fertilizer was very statistically significant, was causing high yield of maize. Was it because they were done during the short studies, or those that were doing the long studies? Are we getting it? Are we together?
Yes, yes.
Are we together, guys?
Yes.
Yes,
Yes, sir.
yes.
Yes, sir.
Yeah, we're together.
All right. Thank you. So what I just need to do is
Wrong.
back to this. So what I just need to do is, now I want to call on this variable. So what I need to do is 2 ways. I told you can do it in 2 ways. Now I want to classify my studies that, okay, those studies that are less than 6 years or 6 months, they you should call them short. Their duration should be short. Why the ones that are greater than 6, it should be long. So I came here. All you just need to do here is to call on the same variable that you had, like that data that you had stored. You can see the data we saved this thing was on meta1. So I'll come back here and call meta1. So it's very easy. So all you just need to like go back where am I? Okay, meta1, then this dollar sign duration group. So I'm telling it that okay, go into the meta and create a duration group for me. Just group it for me. These are two methods. So then I create we'll call it, what's the name of this thing? If else. There's this kind of statement. There's the name of this statement, a conditional statement here. So this is a conditional statement that says, oh, this metal data duration that I created, I'm saying if metal duration is less than 6. So it's going back into meta1 to check if metal duration is less than or equals to 6, call it short. So it's going to create a table entirely for you. But if else, if it is greater than, less than 6 rather, you call it short. But if it is greater than 6, else, call it long. So it creates something like this for you. Object metal data not found. I don't know, do we have any issue as regards this function I wrote here? So I can re-explain.
My own concern is just that you are not recording this class.
It's recorded. It's recorded.
It's recorded, I mean, thank
Yes,
God.
yes.
Thank God.
Okay, thank you.
It's recorded. So all you just need to do is like just follow what I type. So this is where you play along, like play along with. So the name of the file that you like, the name of the you saved when you wanted to run your meta analysis, you named it in a variable. Do you remember? Like, what is the name of that variable that you saved it into? So you call on that variable. Me, I saved it in meta1. Let me show you guys. But I don't want. Do you see it? I said when you run the meta analysis, save it inside this variable meta1. Do you get it?
Yes, yes.
Okay. So all I just need to do is just put this dollar sign and call it. Okay, I want to create a duration. Now, your own could be probably location. I will just call it location group. Call it any name that you want to. We understand it here. So it's just trying, then you put this conditional statement. We call it conditional statement in programming. So if else, it's trying to tell you that, okay, if this metal duration, like your metal duration on this, so it's going back to your data. What you're trying to tell you, it's go back to this data. It's to look for duration. So you know, like, okay, this is duration. That means checking through this column. Then it goes back to this place and says, if these things are less than or equals to 6, anyone that I feel that he saw that it's probably they are less than or equals to 6 is going to call it short. That means creating another column for you. Then if it is greater than 6, it's going to call it long. Are we there?
Yes.
All right. So when you do that, all you just need to do is like, now it's already written on it that when you run that, it shows that okay, it has created 2 columns for you. Now this place, what I try to do here is, what did I do here? Okay, I'm coming. Let me run this. Yeah, so I create a conditional statement here already. So what I did earlier was in this place. So what we did here was to create another column that just define. So what you'll be having here is it will create another column here. Then it will be calling it short, long, short, 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 long, short, something like that. So everything will be written here. That's what we are telling the how to do at that moment. Then if you can come here and update it, okay, meta1, your subgroup is data duration group, something like this. So now if you check this, it's running the analysis for you. So It's creating the analysis. This is the first method. I'm going to show you the second method. So after doing that, you save it, you call on update. Update is telling you, okay, do the same thing the way you ran it for just do the forest plot for me. So do the summary analysis all over again, then create a subgroup here, call it data duration. So what's the name of the subgroup that you want to create? Data duration. Then you can see it's giving me the standard deviation of each of these two subgroup over here. You can check below. So I have everything down here. Then the same method, run your meta analysis for it. Okay, I think there's a mistake here so far. I think I made a mistake. I made a mistake here. All right. I think we could have just run. Let's do this from here. Let's see. So the summary statistics and the forests. Let's try it together. I didn't later use this method, so let's use summary. Just give me the summary of meta one dollar duration underscore group. Yeah, so let's run this, then run this medical coming in the forests. Let's see, probably we just maintain the other method. Interesting. Forest default this. Oh, I think I get where the problem is coming from. So all right, so this is not even supposed to be there. So when we run the meta, so when you create this function, what you just need to go ahead to do is call on meta sub. So you want to do the subgroup analysis already. So currently there is inbuilt on, let me check whether I still have it here. Okay, these are the ones I've done before. So all you just need to do is come back here and do the meta continuous, like you want to run meta analysis on the subgroup that you already created. Now, how do I do that? So what I just need to do is another name. I can call it meta sub. Then I think let's use this method. This one is quite more easier. So meta sub, then the same thing that you did earlier. I don't need to explain these edges, but all you just need to do here is just called subgroup. Then you call on duration group. This is the duration group that you're trying to like work on. Then you run it. What is happening? Expected in subgroup is working now. So all we just need to do is the summary. So when we have the summary, then we run the forest. That's the same method that you have been doing. I hope it's doing this forest plots zoom. Okay, let's try to check it out. Okay, so if you look at this, the data then duration here, what I just need to do is like call on that particular data, and then I'm trying to create a duration group. Same method. If data duration, dollar duration is less than or equals to 6, call it short. And if it is greater than, call it long. So what happened is when I do this, it tells how to create another column and subgroup it into either short and long. Now, if you look at, probably I named something duration.group before, so it was not up, like it's not working earlier. So Now it is working. If you look at the last column to your right here, you will see that what we just did. Do we get that? Are we together?
We are together.
Are we understanding or we are confused? Are we getting it?
Yes,
So I'm
yes.
lost though.
Where are you lost?
This last column that is saying short, short, long, long.
I'm coming. Let me come back. Let me see if it's okay. All right. So together.
Yes.
Yeah, so this is for eager
Yes,
regression. Nothing changed here. So, I told you after the eager regression, you want to be sure. Okay, eager regression tells you we noticed that it was greater than 0.05. We knew that it was symmetrical. Now, we now want to do subgroup analysis. This is subgroup analysis. We want to see if those moderator, what were the moderator that we identify in our data, duration. But we had not created this before. We only had duration as 4666, something like that. Then I came here, I created a function that says under data, this, the table, the data duration. This dollar is like, it's a sign in assignment variable in programming. It's just like it goes into the parents and creates like a child within the parent. So it's just like creating another column. So it's checking into what I have there. So it says data duration. If the duration under data is less than or equals to 6, create a column that we already known as duration group. So this one is telling you create a column that's already known as duration group. Now, if you check under data, duration under data, and you find out that anything is less than or equals to 6, call it short. Else, if it's greater than 6, call it long. So that's what brought this table this new table that we had here now. Did you get it? Are you still there, Gideon? Hello? Are we still on the call, please?
I dey hear you. I can hear you.
Oh, are we lost?
No, we are not lost. Though.
All right, so why am I? Okay, let me just ask personal. Let me get to know everybody.
Yes, I think it's clear. It's clear.